Hi everyone, I'm Letian, and in this video I will explain 2020 Kelantan Addmath paper 2 question 8. So in this question it gives us a normal distribution with a standard deviation of 100. The x-axis over here refers to the score of the students. This one is score. So let us look at the part A1. State the mean of this normal distribution. So mean, also known as average. Normally, the mean or the average is the number on the center of the normal distribution, this one. So the mean is 500. So A1 mean is equal to 500. Now let us move on to part 2. It is found that 80% of the students did not qualify. So Ahmad scored 585. You want us to find out if whether Ahmad qualified or not. So to approach this question, we can first let X to represent the score of the students. And then we can use another unknown to represent the score to qualify. Let A equal to score to qualify. So this A is an unknown number. We don't know what it is right now. It could be 400 or 450. It could be a number that people have to score greater than this number in order to be qualified. So if the person score of the students is greater than the qualified score A, the probability would be probability to qualify. And then but then the question tells us only the probability of not qualify. Did not qualify. So we have to use the inverse of it. Probability to qualify is also 1 minus probability of not qualify. So probability of not qualify is 1 minus 0.8. So probability to qualify is 0.2. So in the form of normal distribution, it actually looks like this. So this is a normal distribution. There will be a mark for qualified, which is A. Let's say it's here. And then the probability to qualify, which is the person who is greater than A. The area of the graph here is 0.2. While the people who is not qualified, they are less than A. This part is 0.8. So from the area of normal distribution, you can get the probability of an event happening. Okay, but then what the question wants us to find is A. Basically, because we need to know what is the mark to qualify first before we know whether Ahmad is qualified or not. So we want to find A, this one. Before we can find A, we need this formula because we need the standard Z-score table to find A. So we need to convert the X into the Z-score. This formula we need Z equal to X minus mean divided by standard deviation. And we know that the mean is equal to 500, and because this one, and the standard deviation is 100. Standard deviation is 100. So we can say that we write this probability z greater than a minus mean is 500 divided by standard deviation 100. The probability is 0.2. Okay, now we need to refer to the Z-score table to find out this probability 0.2. What is the Z corresponding to it? Okay, so from the table, we find that it is 0.842. The Z-score is 0.842. So 0.842 equal to this part, a minus 500 divided by 100. A is equal to 584.2. So this is the mark for any student to qualify. This one. So we can write Ahmad score of 585 is greater than 584.2, which is the qualified score. Therefore, Ahmad is qualified. Okay, let us move on to part B1. It tells us a student is chosen at random, and it asks us to find the probability that the score is between 400 and 680. So we can express it in a mathematical form. Probability score is x between 400 and 680. Again, we want to convert it into the Z-score first. Z is equal to the x minus mean divided by standard deviation. So we convert it, probability 400 minus mean 500 divided by standard deviation is 100. X is become Z, then 680 minus mean 500 divided by standard deviation 100. Okay, so it's become -1 and 1.8. Okay, so this expression, if we were to draw it in a normal distribution graph, will look like this. So I label -1, 1.8, and then highlight the region in the between. So this is the probability that we want to find right now. But we are not ready to find it yet because our Z-score table only allow us to find the probability on the right-hand side, right? So we are unable to directly find the probability from the Z-score table for a range like this. So we need to break this thing up. So we can rewrite this as probability Z greater than -1 minus probability Z greater than 1.8. So in the form of graph, it actually look like this. So this is -1, right? So Z greater than -1 is on the right hand side, and then this one. And then we want to draw Z greater than 1.8. 1.8 is here. And then greater, so it's on the right hand side. So this area minus this area would be equal to the area above. So they are equivalent. Okay, so now let us move on to the next step. So we can already find this thing from our Z-score table, but how about this thing? We are unable to find the probability for negative Z-score value for this one, right? We cannot find for negative Z-score. So we have to convert this further. So how do we convert it? We can change it into 1 minus probability Z smaller than negative 1 minus probability Z greater than 1.8. So it will become like this. This one is 1 minus negative 1. So 1 minus Z less than negative 1. This is still not the end yet. We are still unable to find Z smaller than negative 1. So we need to convert it further. So on the bottom, we can still remain it as probability Z equal to 1, which is the whole graph. But then we flip the negative 1 into 1. So the negative becomes positive. And then we take Z greater than 1. Z greater than 1. So the above and the bottom graph, the area are actually the same. The probability is same, which is probability of Z smaller than negative 1 is actually equal to probability of Z greater than 1, because they are symmetrical, so the area on the both sides are the same. This one is equal. Okay, so we can rewrite this, become 1 minus probability Z greater than 1 minus probability Z greater than 1.8. Let's substitute in all the values from the Z-score table. Z greater than 1, the probability is 0.1587. And then minus of probability Z greater than 1.8, which is 0.0359. So the final answer is 0.8054. Okay, now let us move on to the part 2. Part 2 told us there are 1252 students that score between 400 and 680. So it asks us to find numbers that qualify. So we can express this in a more simplified form. Basically, the students that score between 400 and 680 is 1252 students. And the probability is, we have find it in the previous part, 0.8054, 0.8054. And then we want us to find the number of students that qualify. So right here, qualify. Also means the score is greater than the qualified score. So they want us to find the number of students. This one we want to find. And the probability of students qualifying is, remember, 1 minus probability not qualified. So the question told us the probability to not qualify is 0.8. So 1 minus 0.8 is 0.2. Okay, now we can find number of qualified will be equal to 1252 students, this one, divided by its own probability of the score between 400 and 680, 0.8054. And then we want to find the number of students that qualified. So we multiply that by the probability of students that qualified. 0.2. Type in a calculator, you get 310.90, also equal to 311. Okay. Basically, on the top, the probability of qualify. This one is probability of score between 400 and 680. The reason we can use the ratio between the probability to find the numbers, because we assume that when the probability is higher, the numbers is also higher. Basically, they are just have the same ratio. So we can use the ratio of the probability to find the ratio of the numbers of the student that qualify.